Hello, everyone. All right, so let's keep working on linear systems. So hopefully you've done lesson one and figured out graphing, substitution, and elimination. Now we're going to apply them to word problems. Okay, so we're going to look at some word problems and figuring out uh, some equations from them, and then solving them using the techniques we have, and going from there. All right, so let's try some. So the first one we're going to look at here talks about Bayview Lodge. So a weekend at Bayview Lodge costs $360, and that includes 2 nights accommodation and 4 meals. So if you stayed for 2 nights, you had 4 meals, that cost $360. If you stayed for the whole week, that's going to cost you $1,200 for 7 nights and 10 meals. How much does one night cost, and how much does one meal cost? So anytime we have a word problem like this, we're going to have to do a little bit of definition at the beginning, right? We're starting off with words, and we have to translate this into math. Right? We're starting off in English, and we have to go to math. So we need a sort of a translator tool. And what those things are being called are let statements. So what we're going to do is we're going to let x represent a variable and let y represent a variable. I just chose x and y because you could have gone with, since it's nights and meals, it could be N and M. It could be any letters you want. I just chose X and Y for simplicity's sake. So we're going to say let X be the cost of one night's stay. So anywhere I have any equation that has an X in it, that X is going to represent the cost of one night's stay. And Y is going to represent the cost of one meal. So this is our sort of tool that translates from our sentences above into math equations, which we have to develop now. So that first sentence says that it costs $360 for 2 nights accommodation and 4 meals. So 2 nights accommodation, that's going to be 2x. So that's 2 times 1 night stay, and 4 meals is going to be 4y. I'm going to add them together, I'm going to get 360. So we now have a math equation for that first sentence. 360 equals 2x plus 4y. And that second sentence, we can also turn into a math equation. Because we know it cost $1,200 altogether, there were 7 nights, so that's 7 times x, 7 times 1 night stay, and then 10 times 1 meal. So we have these two equations now. We have two equations, two unknowns. We can solve for both x and y. That's a pretty amazing mathematical theorem. States that if you have n unknowns, you need n equations to solve for all the unknowns. To get enough since we have two unknowns here, we need two equations, and we have two equations. We just have to solve them. So what are we going to do to solve them? Are we going to use substitution or elimination? Now, in this case, it really doesn't matter. I'm just going to use substitution because I see the first equation, and I'm like, everything's divisible by 2. So why don't I divide everything by 2? So 360 divided by 2, 2 divided by 2, 4 divided by 2. That gives me 180 equals x plus 2y. Right, I've divided each of the terms, every term here, I'm dividing by 2. Okay, and I get 180 equals x plus 2y. Now that I have x by itself, right, I can get it by itself. And now I have something that I can substitute. I have this 180 minus 2y. And I can take that. Remember, this is all coming from our first equation. But now I can take the information from our first equation and plug it into my second equation. Right? So what I've done is I've taken the first equation, I've rearranged it to get x by itself, and then I've taken that information about x from the first equation and put it into my second equation. And now it's just a matter of solving, right? I can multiply out 7 times 180 gives me 1260. 7 times negative 2 gives me negative 14. And now I have only one variable. The whole point of that was to remove x from our problem so that we end up with an equation here that only has one variable. One variable means I can solve it. I can figure out what the number is. And then bringing the 1260 over to the other side, I end up with 15. So now I have to think to myself, what does that mean? What does 15 mean? If I go back to your let statements, y represented the cost of one meal. So if y equals 15, that tells us right away that the cost of one meal was $15. And I'm halfway through the problem because I have y. I have half the answer. It asks me, what is the cost of a meal? Done. And what's the cost of the accommodation? Not done yet. So why don't we just take our equation here for x and substitute in 15 for y. So 2 times 15 is 30. So 180 minus 30 gives us 150. So as you can see, we have our answer that the cost for one night's stay is $150. So we're pretty much finished the problem. Now there's one little thing we have to do still. Anytime we do a word problem, we start with sentences, we translate it into math, we do all of our algebraic analysis, all of our playing around with our equations, and at the very end, though, we have to translate it back into sentences. Sorry. So we need to do one final sentence that states that the cost of staying a night is $150 and the cost of one meal is $15. So always remember that when we do any word problems, we have to end it with words. We really should be ending all of our math problems with a therefore statement, but it's especially critical in word problems. Okay? So just a quick recap. We let statements, equations, solving, sentence. Okay? So it's very important, though, that we get that let statement in there. So let's try another one. This is a little bit more difficult. These are these percent problems. There's a bunch of them. The textbooks love these percent problems. It could be a solution. It could be a mixture like this. It could be interest. They're all very similar. And there's one tricky extra step that you might miss. Okay, so in this case, let's read it. One type of granola is 30% fruit. The other type is 15% fruit. What mass of each type of granola should be mixed to make 600 grams of granola that's 21% fruit? So you see, we have to get somewhere in between. There's 30%, there's one that has a lot, the one that only has 15, and we want something in between. So we need to make up 600. Do we get 300 and 300, 200 and 400? What's the ratio that we need to get this amount of fruit? So again, first step, let statements. So let's define x to be how much of the first type, the 30%, and y to be how much of the second type, the 15%. So x and y now represent masses. Right? These are masses, and we're measuring them in grams. And we can come up with two equations. The first one's quite straightforward. We know that we need 600. So right away, if I add the two together, if I add x and y, x is how much of the one, how many grams of the one stuff, y is how much of the other stuff. If I add them together, I want my total, which they're telling us is 600. Now the second equation is a little bit more complicated. 30%, right? 30% is not a number. 30% I have to represent as 0.3, right? That's right, because 30% really means 30 of 100. Percent means of 100. Per cent, from French, 100, per. So 30 out of 100. So really that number, 30%, is 0.3. Similarly, 15% is 0.15. Okay, so if I multiplied 0.3 times how much of the 30% granola, let's say I have 300 grams of the 30% granola. I don't know if that's the answer, but that's just picking a number, less than 600. Let's say I have 300 grams. So if I multiplied that by 0.3, that would tell me 0.3 times 300 is 90. So that's telling me that there's 90 grams of fruit in that first amount of it. And the same with the 15. If I multiplied it by 15, that would tell me how much fruit. And if I added them together, that would get me the total fruit that I want. which would be 600 times 21%. Let me write that down to make things a little bit more clear. Okay, so 30% of x represents, so this first equation, let's go back here. This first equation really is saying the total masses, how much we have. This second equation is talking about the mass of the fruit. Right? I know that I'm going to get a certain amount of fruit from the first one, right? I know there's a certain amount of mass. X represents how much granola we have. And if I multiply by 0.3, that gives me how much fruit I get from the first granola. If I multiply the second amount of granola by 15, that tells me how many grams of fruit I get from the second granola. And if I add them together, I'm going to get my total amount of fruit. And the total amount of fruit is going to be the total amount of granola multiplied by 21%, which is what we want, right? So this equation really tells me how much fruit I have. So we take our amounts and we multiply by our percents, and we end up with the amount of fruit. Now notice I'm just going to rewrite this as 126 because that's 21% of 600. So really I want 126 grams of fruit. Okay, I need 126 grams of fruit. And I need to get that from my first granola and my second granola. So now I have two equations, two unknowns. Let's get to work. So let's take our two equations here. Substitution will be the easier one to use in this case because I can just get x by itself. Take the y to the other side, it becomes negative y. Right, subtracting y from both sides. Then my second equation, I don't like the decimal, so let's multiply the whole kit and caboodle times 100. So 100 times 0.3 is 30, 100 times 0.15 is 15, 100 times 126 is 12,060. This is just, you didn't need to do this step. It's just the decimals are kind of not satisfying. So let's multiply them out. Multiply everything by 100. Now we can replace our x. Plug x into there. So instead of writing x, we write down 600 minus y. Now we can do our little rainbows here, multiply out things. In this case, it'll be negative 30 plus 15, which is negative 15. We're going to subtract 18,000. We're going to get negative 5,400. Divide both sides by negative 15, and we get 360 grams. So this is telling us, remember, we need to go back to our translation. We need to think about what this means in terms of the problem. So 360 means 360 grams of the 15% granola. And then we can solve for x by plugging 360 back into our original equation here, because we know it's 600 take away 360. So that's going to be 240. Right, because these two numbers, 360 and 240, they had to add up to 600. That was our first equation. And that tells us finally, remember we have to go back to a sentence, that you're going to need 240 grams of the 30% granola and 360 grams of the 15% granola. Once I added those two together, right, I added 240 grams of the 30%, 15 grams of 360 grams of the 15%. I'm going to end up with 600 grams, right? 600 grams, because those are going to add up to 600. And I'm going to end up with 21% granola. All right. So again, let statements, equations. That's almost the hardest part is coming up with these equations here. Okay. We have let statements. Once we get to this point, it just becomes a mechanical problem that we can just work our way through. And don't forget your therefore statement at the end. All right, last one. This one's a tricky one. Okay, these are the tricky. The speed problems are tricky. So let's say we have Nick. He's going to drive 500 kilometers. He's going from Windsor to Peterborough, and it takes him 5.5 hours. He drove part of the way at 100 kilometers per hour, and the rest of the way at 80 kilometers an hour. How far did he travel at each speed? So we're asking about how far. We're asking the distance. So our variables are going to have to be the distances. So we're going to let x be how far they drove at the first speed, 100 kilometers per hour. And we're going to let y be how far, the distance. Both of these are distances in kilometers, right? These are distances in kilometers. Keep that in mind. We're talking about distance, right? Oh, wait a sec. That's going to get in the way. Now, the first equation is quite straightforward. All right, we know that he's traveling 500 kilometers. So x and y, if we add them together, the distance that he travels at the one speed, the distance travels at the other speed, if I add them together, I'm going to get the total of 500. Now, speed is equal to the distance divided by time. Right? How far you travel divided by the time it takes. I'm going to rearrange this equation a little bit. I'm going to multiply both sides by t. You'll see why. Okay, which tells me that the distance then is going to be equal to the speed times the time. And now I'm going to divide both by speed. I make an equation here that the time it takes for you to travel is going to be the distance traveled divided by the speed. Okay, so time is distance divided by speed. And why am I doing this? Because I know the total time. So I know that the time it takes me to travel at the first speed, the time it takes me to travel x kilometers per hour, plus the time. Wait a second. Let me just fix this. Sorry, typo. So the time it takes to the total time was 5.5 hours, right? So the time it takes me to go one of the distances plus the time it takes me to the other distance is going to have to be 5.5. However, what is the time that I travel x kilometers per hour? What is the time I travel at 100 kilometers per hour? That's going to be the distance traveled divided by the speed. We don't know the distance. The distance is x. The speed we know is 100. So I can come up with this equation. The distance it took, is x divided by 100. This is the time it takes me to travel x kilometers. And this is the time it takes me to travel y kilometers because I'm traveling 80 kilometers an hour. And the two times together is 5.5 hours. Okay, so this tells me now exactly so this first equation is worrying about distance. And this equation is worrying about the times. Right, because they're giving me the distance and the time. So I need to come up with an equation for both. So now I have two equations. Now I have two unknowns and I can solve it. So this little bit here is a bit tricky. If you get stuck on that, just watch it again. Okay? That's the nice thing about all these videos. Please, if you get stuck, there's nothing to stop you from watching it again. Okay? And it's not for my YouTube views. I'm not here for the views. Like, share, subscribe, and all that sort of nonsense. Okay. Anyways, let's go back here. So how do we solve this? Fractions. Yeah. Fractions. That's gross. Let's get rid of these fractions. Okay. Easiest way in this case to get rid of all the fractions. Let's multiply by the common denominator. What's the common denominator of 180? And it's actually 800, but let's just multiply by 8,000 just to make our lives easier. Okay, we're going to multiply everything here by 8,000, right? Because 8,000 divided by 100, that's going to give me 80, and 8,000 divided by 80, that's going to give me 100. And also this equation, I'm going to multiply it by 80 to give me, I want to use elimination. I've used substitution. I want to use elimination for this one. So my first equation here, I'm multiplying by everything by 8. So 8,000 divided by 100. So we're going to multiply this guy by 8,000. Multiply this guy by 8,000. So 80 divided by, so that's going to give me 100. And this is going to give me 80. And I'm going to end up with 44,000 for the other one. And multiplying the first equation by 80, notice I just wanted these numbers to match here so that I can subtract them for elimination. Okay. Really, I just wanted to do elimination because I hadn't done it yet. Anyways, So again, multiplying both equations by something to make the first coefficients match, so that when I subtract them, they cancel out. So 80 minus 100, that's 20, negative 20. Why? 40,000, take away 4,400, negative 6,000. Solving for y, I get 300. What does that mean again? What was y? Y was how far I traveled at 80 kilometers an hour. So 300 kilometers traveled at 80 kilometers per hour. And quite obviously, that means that the distance traveled at 100 kilometers per hour is going to be 200, right? Because they have to add up to 500. Or just plugging it in, I end up with 200 kilometers. And again, therefore statement, and we're finished. All right, that one was a bit tricky, mostly because of this time equation. It's a little bit complicated. All right, so don't forget your therefore statement at the end. Right? They travel 200 kilometers at 200 kilometers at 100 kilometers per hour, and 300 kilometers at 80 kilometers per hour. All right? So these problems, when we're solving linear systems problems, really the hard part is coming up with the correct equation. Once you have the correct equation, it just becomes a mechanical problem, and I'm sure y'all are capable of doing that. It's just some of those equations, coming up with some of those equations are tricky. But this is 3 examples that are very similar. The first one was just a simple linear equation. The second one was dealing with concentrations. It could be concentrations of anything. That was fruit. It could be concentrations of, what are some of these other examples that they like to use? Acids. How many percent acid do you have to mix together to make a percent acid that you want? Interest as well. When we're making investments, they all end up looking very similar. And then there's these speed ones that are also fun too. All right? Okay, so I hope you're all doing well. I hope you guys are all getting into the swing of things. Again, I did send you guys a note, but just so it's clear, I can't mark a big stack of JPEGs. I can't. Okay, please come up with a way. Like you can take a bunch of pictures and then import them into Word if you'd like, and then send me that. Or if you want, there's nice scanning software, free scanning software online, Adobe Scan or Office Lens. Please just come up with a way that you can get me one document so that I can mark that. Okay, much appreciated. All right, so again, hope you guys are doing well. I'll be posting this today. This is Monday, and have fun. All right, take care.